So this is our next reaction, combustion reaction. And again, we're writing chemical equation. We're predicting, we're writing, as well as we're writing the complete and net ionic equation and drawing microscale illustrations. So the example that we have today is butane gas. And notice how butane gas is a hydrocarbon. I do want to also mention that not only hydrocarbons, but also substances that have hydrogen, carbon, and oxygen as well. Anytime you heat those substances up, whether it be an alcohol or whatnot, you also, and you burn it in oxygen, you've got a combustion reaction, okay? So butane, I gave you the formula for butane. You're not expected to know that formula. It's an organic compound. So the formula looks like this, C4. We're going to start off that reaction with C4H10. And butane is a gas, as noted right here in the statement. It's going to react with oxygen, which is a gas, and it's going to form carbon dioxide, as predicted, which is a gas, and water. And this is going to release a lot of heat. So there's going to be a lot of heat, and there's going to be light to this reaction, which you'd have to observe if you wanted to add those two ideas, and feel. You would observe the light, and you would feel the exothermic heat from this reaction. So let's go ahead and balance this reaction out. In balancing this reaction, I have 4 here and 1 here, so I'm going to put a 4 coefficient. I have 10 here and 2 here, so I'm going to put a 5 coefficient. Now I'm going to count out my oxygens. I have 8 plus 5 gives you 13. I'm going to use a fraction. I'm going to use 13 over 2. Now notice, after using that fraction, you have to get rid of that fraction, and so multiply everything by 2. So when you do that, you get rid of that 2, get rid of that 4, makes it 8, multiply that by 2, you get 10. So these are the coefficients that make this equation balanced in the end. So the net ionic equation for this, again, we're looking, I should mention the driving force. So the state of matter of this water is actually a gas because there's so much heat expelled from this. So the driving forces would be a lot of. There's the formation of gases and also heat as well as light. So there's 3 different driving forces, and there's always multiple driving forces, or not always, but there can be multiple driving forces in a reaction. So a complete ionic equation, interestingly enough, is, again, we only dissociate things that are aqueous, and that's why we put those states of matter in. So these are both gases, and all these are all gases. So the net ionic equation is the same as the complete ionic, so I'm just going to put ditto here, as well as the complete ionic, net ionic is the same as the original balanced chemical equation. So now, again, notice how things are covered up here. I'm going to put oxygen over on this side, and I'm going to put 13 oxygen, so I'm going to need 13. And hopefully you bear with me here because there's a lot here to draw out, and I want you to draw those 13 as well. I did a really long one for us. So 2, 4, 5, 2, 4, 5, 10, 12, and then 1 more. Okay, so those are your 13 oxygen molecules floating around in that capped up beaker there. So now we're going to look at the reactant number 1. Reactant number 1 is a gas as well, and so it's C4H10, and there's 2 of them. C4H10. So then we go over to here in the product, and there's a lot to be placed into this product. So you'll see 8 carbon dioxide and 10 water molecules. Again, both are gases, so you'll see a lot of them. So you'll see 1, 2, 3, 4, 5, 6, 7, 8. We'll squeeze that one in. And we're also going to see water as well. And we're going to see 10 of the water molecules. And I'm going to make them smaller. I don't have make the pen smaller so that I can fit 10. And they're mixed, pretty well mixed in this solution here. Okay, that should be 10. So those are your 10 particles. And of course there's heat. So I'm going to put in here, and there's going to be heat expelled out because it's very exothermic. You'll feel it to be very hot. So I'm going to put the delta symbol right there. And there's also going to be light. So I'm going to put HV in here as well to show that that light will be expelled out of that beaker. This concludes it.